thanks for coming to today's webinar about how to mesh a tire tread with Coreform Cubit. I'm Matt Cederberg, Chief Strategy Officer at Coreform, and the webinar today will be presented by Karl Merkley, who's a longtime Cubit developer. Today we will focus on the following items. First of all, introducing Coreform Cubit and discussing why this software has been used for decades to create hex meshes for tire modeling. Then Karl will demo live on 2 models some key features with Coreform Cubit. So we'll be focusing on how to detect and resolve geometry issues when meshing tire treads, specifically how to use the Coreform Cubit pave and sweep hex meshing approach to mesh tire treads, and then how to adjust and optimize for hex mesh quality. And as part of attending live in today's webinar, you'll be able to ask questions to Karl. Feel free to type them in throughout the webinar. We can address them as it makes sense, and there'll be additional time at the end. So in case you're new to Coreform Cubit, Coreform Cubit has been around for quite some time, and it's used often for advanced meshing for challenging simulations. So tire modeling is one of the areas that we see significant usage of Coreform Cubit. The key features that Cubit offers are CAD cleanup and import. We can import native CAD geometry from most major CAD file formats, offering a semi-automated hex meshing procedure that Karl will be focused on today, as well as being able to control the mesh properties and quality, which Karl will also focus on today. Many people that use Cubit use it because they can automate their meshing processes through Python and scripting. And that may be touched on slightly today, but we have a number of other webinars that introduce those topics as well. So with that, let me turn the time over to Karl.
Just a little bit of quick motivation. Why do we want to use hex meshes for tires? Tires are rubber, nearly incompressible materials. That presents some unique problems, especially when we're doing contact. And we've seen that hexahedral elements perform better in contact so that your solution actually converges. There's nothing worse than to run a solution for an extended period of time and get no answer out. Hexahedral elements will run faster than tetrahedral elements. There's simply fewer degrees of freedom. One point in time, I think we calculated out that a single node in a tet element on average is connected to like 27 edges, where with a hex element, you're connected to, at most 8 other, in an optimal, 8 other elements around a single node. Fewer degrees of freedom, smaller analysis, faster run times. Then Cubit has long been used to create tire meshes by leading tire companies. Part of the reason for that is tires are built in layers, and those hexahedral meshes can help capture those layers. When you're doing wear analysis, it wears off in those layers. Once again, those hexahedral elements can be used to adjust that and to do wear analysis. So that's some of the reasons why people choose Cubit to create hexahedral meshes for doing tires. And Cubit, as Matt mentioned, has the automation capabilities so that we can run things over and over. So the basic workflow in Cubit is we import the model. Frequently, we have to decompose the model, clean up the model, and then mesh it. In this particular seminar, I'm not going to worry about the decomposition. We have a couple of other really good decomposition webinars already out there. If you are new to Cubit and you want to get some decomposition techniques, these two, your first 15 minutes using Cubit and semi-automatic hex meshing of complex parts using Coreform Cubit, give some really good decomposition techniques. I'm going to actually spend most of my time doing some live demos showing some geometry cleanup and meshing on a couple of fairly simple tire treads. Now, I'm going to grant you up front within the webinar, these are simple, but they show some techniques that I wanted to demonstrate. So I think we've learned how to resolve the geometry, use the pave and sweep, and we'll just use some geometry techniques to help control our mesh. So here's this model that I brought in. Simple tire tread. If I come in and just say mesh volume all, just using the command line because I am a power user, these two volumes don't mesh. All right. If I look at this, I see a triangular surface. I would normally want to pave and sweep these models from top down to the bottom, which would make sense, but these two obviously, Cubit wasn't able to do that automatically. Whenever I have a triangular surface on my sweep direction, that's a problem. I can't put a good, well-formed quadrilateral mesh on that surface. And then these surfaces on the front side are just complex. In general, tire meshes, we want to do a coarse, generally we want to do a coarse mesh because we're going to use this mesh replicated many times, or so these small features frequently we want to just get rid of. So let's do some compositing and some selection techniques to show how to get rid of that. If I come into surface selection, and the hotkey for that is 2. So I may switch back and forth between a 3, which is the volume selection, a 2, which is a surface selection, and a 1, which is the curve selection. I'll be using those hotkeys. And I come and select the surface and say, select continuous. That selects all of these surfaces in a continuous set. So that's actually really nice that I can do that. Control click here and do a select continuous again. So now I just need to single select these two surfaces. And once those are selected, I can do a right click and a composite. Okay, let's just do that on the other side so we can see what's going on here. We'll do the same thing just to replicate that. It's pretty fast. Draw that. Select here, select continuous. Select here, oops. Do continuous. Get these other two surfaces. Tab key to get the one that I missed, and composite. Now let's just try meshing this again. All right, it still did not mesh. Well, okay, we know one of the reasons why. We have to composite the surface together. So let's go ahead and select this surface, tab key, and do a select similar surfaces. Actually, I want to get both of these and do a select similar surfaces. And that gets both on both sides. So I don't actually have to go pick these individually. Do a composite. Okay. And
Please
you'll
do you
notice
mind
that
again,
this,
Carl, why compositing is helpful for making the hex mesh?
because without it on this surface, we call the surface between the source surface and the target surface, we call these linking surfaces. That's just the terminology that Cubit uses. These surfaces have to be either a map or a submapped surface. So I've got to have a nice quadrilateral mesh so I can sweep from top to bottom and create those layers. So let's try meshing that again. Okay, that doesn't surprise me. There are some things going on in this model that still is not automatically hex meshable. So I'm going to turn vertex visibility on. Oh, look at that. So these surfaces, even though this surface is composited, the surface on the side still has all these really small features. So if I go into curve selection mode, select those curves, select similar curves. That's going to give me the ones on the other side of that volume, and composite. Do the same thing here. We get these curves. Select similar curves. Make sure we got them. Yep, we did. And composite. Okay, that's great. Uh, Interesting. We look in here and there are some very small curves in there. Now, if I don't know whether this will mesh or not. There we go. If I mesh that to start with, you'll notice that I've got some really funny shaped elements in there. Compositing these curves together is one way to help control our element quality. What we want to do is Qubit wants to acknowledge that vertices may have some value. You may need to attach something at a vertex. So the mesh is there at those vertices by default. I delete the mesh. I come here and select this curve and I say select continuous, select similar. That gets me both sides. Once again, composite those together. I'm going to do a shift rotate so I can just rotate a little bit about the origin that I picked. Select continuous, select similar and composite. Select my volumes and mesh. Okay, there were some other curves here that I might want to go ahead and composite together just for the sake of time. I'm not going to spend a lot of time on that model. So if there are questions about that, primary thing with this model, we simplify complex surfaces in a way that we can do a sweep from top to bottom. We may have to composite the curves on those surfaces as well. Plus, we use our simplification to do that, to improve the mesh quality in those areas. And there are further simplifications we could have done on this model to improve that. Okay, so we composite to make objects sweepable, to control the mesh size and to control the mesh quality. Use the right-click options to select continuous, to select similar, and also to access the composite. So that's just a really quick overview on this simple model of how to do some of those things. Okay. Now, this next model is a little more complex, but we're going to spend about the same amount of time. So this is going to be a relatively short webinar. But this model is a little more complex, and there are some issues with this model as well when we first bring it in. So let's go ahead and reset here. Bring in this other model. I've got a journal file over here that I'm just playing that brings this in. Let's set the vertex visibility off to start with. Once again, I'm a power user, so I use the command line every once in a while. Okay, I've got all of these parts here. And notice this is the way I actually received this model. I received it from the CAD system where these pieces had already been cut out. Qubit has some great tools for doing web decomposition, but it's not a CAD modeler. There are certain times when doing these kinds of decompositions in the CAD tool is the way to go. If you can get your designers to do that and you can describe exactly where you want them to cut that, sometimes that's a really useful thing to do. So once again, let's go into volume selection mode, select all the volumes here, and mesh them just to see where we're at. So we haven't done anything to this model. You'll note that there's some volumes here that did not mesh. This one's, that's a very simple model. That one just meshes. Great. Some of these others also mesh just great. But there's some issues on these pieces. One of the places, whenever I have issues when I bring in models and I need to figure things out, one of the places I come to is the power tools. The default is the geometry power tool. Come in, set my options. Let's just do an auto size on that. Say done, and then analyze these parts. So I'm looking at all of these parts, and it says I don't really care about my assembly checks. I do typically care about small surfaces. So this is a place where we can, I will actually use the fly-in and find that. All right. This is something left over from the CAD modeling system. I have a curve here, and I have a curve on the other side that are just really small. They're not real features at all. So when I have that selected, I can come over once again to my graphics window, right click, and just say remove. Select this one, remove. If I reanalyze again, it says there were 4 small curves there. I analyze, and those small curves go away. I will almost always focus first on removing small surfaces because that will fix many of the small curves. But then there's also some bad angles that are 0. Actually, I think let's zoom to this one for this example. All right. So I look down inside that sipe, and there is something weird going on there. This is a small feature, much smaller than my mesh size, but it even comes down to like a 0 width thickness there. That is something we've got to get rid of. So I'll do a 2 key, get back into surface selection, and once again, just right click and now remove. And that removed, it says that small curve got deleted. While I'm here, as I'm just turning around, I look at this, I see, oh, there's a small surface there. Right click to remove that. Let's redraw and look at this other one. Draw that. I have the same kind of thing going on. Am I on the right side? Yes, I am. Same kind of thing going on here. Click, click, right click, remove. Tab key to get the correct surface and remove. Okay, great. Let's look at the volume underneath. Okay, so there were imprints created by the CAD system of those things there as well. So let's go ahead and select that small surface, remove it. We'll get these 2, remove those. And that's cleaned up pretty much on that side. That's great. But we have the exact same things going on the other side here. And rather than go through the right clicking, just as a quick demo of Cubit's journaling, here's the commands that were generated to clean up the right-hand side there. So if I go ahead and just highlight and play those selected, move my journal editor back to my other monitor, and we come in here, go into transparent mode and zoom in, and I see I just have the one line on both volumes through there, which is exactly what we wanted to see when we cleaned that up. Now, in our power tools, and we look at those bad curves, they all say that they've been deleted. We also have these assembly checks. We have volumes that overlap, surfaces that are mergeable. So there are a number of things here that we're still not done. This concept of imprinting and merging is a critical concept in Cubit. We come back to our geometry, go into volume, and select imprint and merge. One of the things I find with new Cubit users is they forget this imprint and merge step, and they create their mesh. It looks beautiful, but it's not a conformal mesh when they start looking at it. Imprinting takes all of the curves, matches them onto the other adjacent surfaces, and merging then takes those surfaces and merges them together. So if I apply here and do imprinting and merging all at once here, everything imprinted, but when I merged, I got this result. And that's part of the reason why I wanted to do this webinar, is just to make sure to tell people when you merge, make sure you look at the results of that merge. I'm merging solid bodies here. I'm not merging sheet surfaces that I only connect at one edge. Why did I have 6 pair of curves that merged and 63 pairs of surfaces? I would expect that that should have been 0. So something went wrong with that imprint and merge. Now, from the command line, one of the things I tend to do, I will do draw surf with, I have a property of surfaces is merged. So I can say draw surface with is merged. And over here on this right-hand side, something didn't work correctly with a basic imprint and merge. If I draw this volume again, draw this volume, where that sipe exists, I didn't get the sipe from both pieces. So when that happens, what most likely has happened is in the CAD translation somewhere, tolerances are off. Cubit uses a very fine tolerance on the order of 5/10,000ths. Most CAD systems have a tolerance on the order of 6/1000ths. So in order to fix this, we can come into imprint and merge and do a tolerant imprint. I'm just going to select these bodies. I'm going to give it my standard Creo tolerance of, 6/1000ths. And I have the merge option set. So it will imprint and merge. And I apply here. And now it comes back and says, hey, I consolidated 5 surfaces and 0 pairs of curves. That's the kind of thing I would expect to see as a result of doing that merge correctly. Now I can go ahead, I'm in volume selection mode, select my volumes, and hit mesh. And those volumes all mesh. Now that is a pretty darn coarse mesh for a tire mesh. Maybe what you want, but in general, from the tire meshes I've worked on, that's a pretty fine mesh. So let's select these all again, delete that mesh. So the default size that Cubit picked was on the order of 1. Let's just double that and remesh. That's still fairly fine for a lot of cases, but that's a pretty good example mesh. If we want to see what our quality looks like, we can come into mesh, volume, quality, our quality metrics. I've chosen the scaled Jacobian metric. The default that comes up is one that my friends at Sandia like. It's the shape metric. They're very similar. So I'll go ahead and move my bar out of the way. So on this particular mesh, my quality ranges between 0.5 and 1. In general, anything over 0.3 is great. Positive positive Jacobian greater than 0 is, okay, at least I can get a solution. This is a high quality mesh. And that's what we're trying to do, and that's what we try to create using Cubit. So just to review the points here, use the geometry power tool to find and remove small features. It's a great tool, has a lot of things. Use the right-click remove option to defeature that geometry. Pay attention to the things that come out in the command window, especially in the merge command. If you have solid entities, all surfaces should merge, and you should have 0 curves and 0 vertices merged. You can use the power tool to show you the results of surface overlaps, or you can use that draw surface with is merged to find unmerged surfaces. That's what I got. Matt, any questions out there?
Thank you so much for introducing those tips for modeling tire treads in Cubit. Really appreciate it. Let's see, here's one, Karl. As far as the CAD formats, do you have one that you'd recommend that seems to come in the best with Cubit, like whether it's IGES or STEP or a proprietary CAD format?
We work with STEP. IGES is an additional license already. STEP is way better than IGES. IGES, I actually worked on the STEP committee years and decades ago. IGES, there's a reason it was called Initial Graphics Exchange Specification. It was the first cut. STEP is definitely a step above IGES. It's better. If you have the licenses and you can get the direct CAD models, Cubit supports reading in CATIA and SolidWorks and Creo files directly. If you can get those, you'll get higher quality using the CAD models directly. If you can get a high quality SAT file out of your CAD system, that's the ACES SAT file is the default model in Cubit. That frequently works. I would generally recommend getting the CAD models directly. STEP works pretty well.
Okay, great. Let's see, just a couple other comments telling you thank you. Maybe just the last comment or question, Karl, is as far as export formats that Cubit sends out to with the various solvers, which solvers supports the hex meshes generated from Coreform Cubit?
Like pretty much all of them. Let's see. If we go to our file export menu and we look at our file types here, Exodus and Genesis, those are formats used at Sandia. They're also fairly widely used in other tools. If you want to export out to ParaView, for example, ParaView will import Exodus or Genesis files. Abacus, the ANSYS formats, Fluent and Azor, a couple of the Fluent file format, UNV, LS-DYNA, Nastran. So there's a number of different formats that all support hexes. And in fact, hexes are probably the best supported elements across all of those because everybody wants hex elements out of Cubit.
Well, Karl, thanks again for the preparation and presentation, and we'll catch you all at another webinar.